Well, good afternoon, everybody, and welcome to another fabulous webinar presented by CAD Technology Center. I'm your host today, Don Rasmussen, and today we are going to talk about the good, the bad, and the pipe routing preferences in Revit MEP. I figured for today's webinar what we would do is go through and actually set up a no-hub routing preference. Simply because that's something that a lot of us on the AEC side of design have to do inside of Revit simply because it doesn't exist. Now I've spent the morning downloading some content both from a couple different no-hub manufacturers, so you guys will probably recognize some of those parts and pieces. And then I played with it a little bit just to make sure obviously that some of the stuff would work and so I would know what would happen. And then I'm going to walk you guys through that process here today on this webinar. So let's go ahead and get started. I'm going to get out of the PowerPoint presentation and we're going to get into Revit. So here in Revit we are looking at the pipe fittings, the pipes types themselves, as well as the system types. Now we're not going to get so much into system types today because we're setting up routing preferences, and routing preferences live at your pipe types level. However, your routing preferences obviously require fittings in order to be set up, and so your fittings need to be loaded into the project. If you forget to load your fittings into the project before you get into setting up your routing preferences, as you'll see here shortly, there is a nice little load families button inside of routing preferences so that if something you want isn't there, you can load it without getting out entirely of the routing preferences. That is possible. But you see here I've got some fittings from ABI Foundry and Charlotte Foundry here, and we're going to use these fittings and or a combination of these fittings to show off how you set up a specific routing preference. Everything else that we see here other than these fittings that we see is directly out of the box in Revit. I am in Revit 2019 for this exercise. There's no difference between 2019, 2018, 17, 16, going all the way back to 2014 in the routing preferences setup. It's going to be the same regardless. And so we're going to walk through a couple of these exercises here. The first thing that we have to do when we're thinking about setting up a pipe type and then setting up the routing preferences based upon that pipe type is to probably create a different pipe type, right? For those of you who've caught my previous webinars and or mini trainings, I go into depth about what pipe types are versus what pipe systems are. But pipe types are basically your materials and or your routing preferences. So if you have a single material that you use different routing preferences on, you will need to set up as many of those pipe types as there are routing preferences and then name them accordingly so people are grabbing the right ones. Other than that, you can differentiate between fittings and routing preferences, but only by size delineation. But the first thing we need to do is pick one of these to duplicate. It doesn't really matter which one because we're going to be changing everything, but the way to create one is to start with a duplication. So with the standard pipe type, we'll go ahead and we'll duplicate that. And we wind up with the standard space 2. I'm going to go ahead and rename that. So I'll right click on it. I'll go to rename and I'm going to name this no hub cast iron. So there I've made my pipe type. The pipe type is complete as far as showing up in the project browser in Revit, but we need to finish some more setup obviously to make it useful. And so I'm going to go ahead and right click on it again and go to its type properties. This would be the same workflow for pipe systems and creating new pipe systems as well. So if I go into type properties here, you'll see I have a bunch of information. It looks very similar to the type level of a specific RFA file or a specific family. Here we have all sorts of information that we can put in for this specific pipe type. If we want to put in information about its cost, where we're pulling the information from, if it's based upon a specific manufacturer, all of that can be set right here. But your routing preferences are right up here. There's this nice edit button. We click on that and that opens up our routing preferences. Now since I have to duplicate an existing pipe type to create a new pipe type basically, Obviously, when I duplicate that, it's bringing in everything else as it was set up on that previous pipe type. I have to go through and redo this all now, obviously, because copper is not what I want as a material for my no hub cast iron. The sizes are going to be different. The material is obviously different. The schedule, the wall thickness is going to be different. So that would be an issue. But speaking of pipe segments here, and this being the first and obviously the most important selection in your pipe routing preferences, you have to start this off with your segments and sizes. Now, if I click in here and I hit this drop down, there are some segments and sizes that are given out of the box and that are pre-set up with you in Revit. However, if you are not able to find the one you want, I just happen to do one here for the sake of argument and to save us some time. If you don't have the pipe segment you're looking for the particular routing preference you're setting up, you have to go and create that. Now, to go and create that is actually, it's pretty simple. You can hit this segments and sizes button right here, which is my preferred method to do this, or the segments and sizes, I'll just cancel out of these things quick. The segments and sizes also live underneath your mechanical settings. So if we go to our mechanical settings dialog box, here's our segments and sizes here under pipe settings. It's the same location. So I'm going to jump back in through the pipe routing preferences. And so your segments and sizes would be obviously your nominal sizes of your pipe, the inner dimension of the pipe, and the outer dimension of the pipe. The materials, or the segment rather, is based upon materials. So when I hit this drop down, this is the same drop down that I get when I go over here and try to load a pipe segment into the actual routing preferences. It's the exact same list. This list is created through a combination of out-of-the-box settings and custom settings that you would create. If you need to create a new segment, which we would have to do if we're using out-of-the-box purely for no hub, we would have to come here to create new pipe segment. When we click on this, we get the new pipe segment dialog box. Now, the new pipe segment dialog box gives you 3 options for creating new pipe segments. Those options are based upon solely material, and then I can pick a schedule from existing schedules that I already have in the project. I can do it based upon schedule and not have to create a new material, pick a material that exists and then recreate the schedule for it. Or I can do both, where I'm going to do the material and the schedule. Typically, I prefer to do both simply because I always want to verify my sizing. It's not that I don't trust necessarily what's in Revit out of the box. I just always like to verify what's there. So, like I said, I already created this, so I'm going to back out of this now. But I just want to, before I do this, I just want to give you guys a little cruise through here to show you what it looks like. So if you click on these 3 dots here to the right of material, that will open up the material library in Revit. Now, it's important to understand that Revit will allow you to make pipes out of carpet. Revit will allow you to make pipes out of air. Revit doesn't really care what material you pick to make your pipe out of, so it's up to you, the person who's actually putting this together, to have the knowledge of the material a little bit, and you do a little bit of research. A lot of this information can be found on specific manufacturers' websites. So what you need to worry about is obviously finding the right material. So here's carbon steel for steel pipe. Here's one that when Charlotte made a custom material, so that when you load in Charlotte items, their custom material is right here. There's nothing wrong with picking that material. What you do need to pay attention to, or at least verify when you do pick a material, is not so much identity, graphics, and appearance, unless you're going to be rendering. MEP seldom renders. There are occasions where we do. If we do get into rendering, we really need to pay attention to these 3 tabs, because that's what drives our rendering and the reflectiveness of the pipe. And we don't want every single pipe in the entire project to be the same color with the same reflectiveness, because then we won't be able to tell the difference, right? So we want to be able to set those per the material. But the physical tab and the thermal tab are 2 areas that we're going to definitely want to verify some of the information, especially when it comes to your isotropic and orthotropic properties. So if I go to Charlotte cast iron here, let's go maybe here. Try to find one here really quick, guys. It's got those tabs already filled out and populated with the right information. It doesn't look like I'm going to find a good one here. Oh, metal, maybe. Physical. There we go. All right. So metal, you can see here, this has this behavior set up inside of it. So it has isotropic behavior, orthotropic behavior, and transverse isotropic behavior. Basically, at higher temperatures, how is this material going to change? Or I shouldn't say at higher temperatures, at any temperature. How is this material impacted? How does it grow or shrink based upon temperature? And then the same thing with thermal. The reason that I say that these things are important is that if you want Revit analytics to be extremely accurate, it is pulling analytical information from some of these settings. And you need to make sure those settings are correct, obviously, or otherwise your analytics are going to be inaccurate. So I'll go ahead and get out of here, and I'll cancel through the new segment as well, considering that I already made one of these, and I'm just going to go ahead and look at the one that I created. So this cast iron no-hub pipe. Now this cast iron no-hub pipe that I made here, guys, I just made some small size, or a smaller size range, if you will, so 1.5 to 15 inches. And again, I just did this for time. Usually I recommend that if you're going to sit down and go through this process, that you sit down with a piping catalog and you just make all the sizes that are available for that specific material. The reason being is that we don't want to have to come back in here and recreate things in the event that we have a project that takes us outside of our typical pipe that we would normally use. We can still limit the pipe sizes that come up inside of Revit by these check boxes here. You have a used in size list and used in sizing. If we uncheck these boxes, when we go to look at our pull down list for our pipe sizes, those sizes would be removed from the drop-down list. So therefore, we wouldn't be able to select them. However, if I hand input them, they would still be available and the pipe would still be able to be drawn at that size. If I unchecked use in sizing, that means I can't draw that size pipe, period, said, done to me, not even if I hand input that value. Another very important thing to check for validation for analytical purposes is your roughness value. We want to make sure that this is a valid number based upon, again, the pipe material that we're using. Obviously, things like PVC, CPVC, ABS, basically any plastic pipe have a much lower roughness value, right? Because they're a much more smooth surface. Something like cast iron has a higher roughness value, obviously, because it has a little bit more friction when something flows against it. So now that I have kind of talked about the segment portion of it and kind of shown you what goes into that, actually, let me back up here for a second, guys. I did forget to mention one thing, and that thing is, if you notice when I click around inside of here, if I double click in a cell, it doesn't matter. If I just click around in cells, it doesn't matter. I can't edit any information in here once it's been established. So the only options you have in your size catalog creation are new size or delete size. So if I wanted to add a size, obviously I have to click new size. But if I were to say, for example, if I wanted to fix 1.5, or excuse me, well, we'll just stick with 5. If I wanted to fix 5, for example, and I click OK here, it's not going to let me do that because I would have 2 5-inch nominal diameter sizes available to me. So if I wanted to fix the 5-inch size, I would have to delete it first and then re-add it. Okay, and that's just how Revit is working when it comes to setting up these size catalogs. So be aware of that. Know that you kind of you should gather all your information and sit down and do this in one big process, because the ability to come back in here and change things is limited. So I'm going to get out of the size catalog and the segments and sizes there, and then I'm going to come in here to my pipe segment and my routing preference. I'm going to drop that down and I'm going to find the pipe segment that I created, this cast iron no hub here. Now, this routing preference, as we go down the list here, we see that we have elbows, then a preferred junction type, and then a junction right below that, cross, transition, union, flange, cap. We don't see a Y in here. If you set up a specific Y fitting, so that is a pipe fitting under the Y fitting designation in the family level, it will not show up in this list. I do, however, see some people who set up a Y as a T inside of the family, and that does mean that you can select it here in your junction type. As you see here, there's one as an example that I loaded in right here. Now, this setting up a Y inside of your routing preferences can be done with this method, but it does provide a bit of a challenge, and that challenge being is you have to draw the 45 pipe coming off of another pipe in the right orientation that promotes the placement of the Y. And I'm going to try to get to this by the end of the webinar, guys, so you can see what I'm talking about with that specific setup. And so I'm just going to simply cruise through here really quick and set up some very fast routing preferences. So I'm going to go with the ABI standard bend on this one. I'm going to keep with the T, and then I'm going to load in just the sanitary T. The cross will probably be a double san T. Transitions will obviously be a reducer. I'll load that in. Now for unions, there can be a couple different scenarios. I don't have any unions loaded in here. We don't show a ton of unions typically inside of the Revit environment. I could see several scenarios, however, where that would not be the case, and we would be placing unions inside the Revit environment. I just don't happen to have a fitting loaded in here for this union specific connection. The flange I have set up as a coupling, and this is one of the first tips of the webinar here, is using using the flange category to set up no-hub couplings. And I will show you how you can do this at the family level to get it to show up here under flange. The advantage here is that if I do have it set up under flange, it's automatically going to place my couplings at every single connection, which I can then quantify and go ahead and put a schedule together and manipulate. And I got a question here about optimizing pipe lengths. There is no native tool inside of Revit outside of the fabrication tools for Revit that allows you to optimize actual Revit pipe lengths. I can do it with fab content in the Revit environment. There isn't a native tool to be able to do that with Revit pipe types like we're setting up right now. It's definitely something we can add to the wish list at Autodesk. It's something that we can look at into making a tool for, absolutely. But as of right now, there are no native tools for that. And then, of course, we got to set up our cap. I'm going to go ahead and grab a plug, and then we'll simply click OK. So now this routing preference has been set up. Let's go ahead and test it. So I'll come into my systems, I'll grab some pipe, and I'll make sure we're drawing with the right pipe type that I created. And so I can see I'm drawing some 2-inch pipe here, and obviously we would want to test some different sizes, but I'm just going to test the 2-inch here. And we just test it by simply drawing. Is it placing the right elbow? Here's the couplings that it's placing automatically that I set up as flanges. And so it looks like the elbows are working okay. Then we shift gears to the T's. So I'll draw a little jaunt off here. Let's make sure that that sanitary T goes in correctly. Probably helps if I draw a straight pipe though, guys, huh? Draw pipe straight, and there the T went in. Obviously I want to verify the T itself by clicking on it, seeing if I can swap this back and forth. You know, obviously it's the sand T, things are a little bit different with specific T's, so it's not an easy swap, but it is flippable. And then do I have my plus sign over here as well so I can turn it into a cross in the event that I have to, and I can. Looks like the flow orientation changes, but again, I can flip that, disconnect some things, reconnect, and be okay. Now I want to check out the cross functionality, make sure that the cross goes in well. So I'm just going to do another create similar on these pipes, draw 2 pipes that would generate a cross fitting. Looks like the cross is being placed okay. I can click on that. I can verify that that's a cross. Now to test the cap, I would simply just click on the pipe, do a cap open ends. Is it placing the right cap? It's placing the right cap. Everything seems to be working out with this configuration, at least at this size. So now that we've looked at setting up that routing preference, let's go ahead and start swapping out some of these parts and pieces in the routing preference, mainly the T for the Y. I want to show you guys how that process works and kind of what I was talking about in terms of having to draw that 45-degree pipe in the right orientation. So if I go back into the no-hub cast iron pipe type, I go back into the type properties and back into the routing preferences, and then I will go ahead and swap out that sanitary T for a standard Y fitting. Click OK. Now when I come out to this piece of pipe, I'm just going to go ahead and do a create similar again. And I'm just going to draw straight off the pipe, just like I would normally with the T. And of course, that's not going to work. Revit is going to get very mad at me and say that this won't work. So it's going to force me to cancel out of this and do it again. So since I just happen to know that this is a Y, it stands to reason that it should be drawn at a 45. That's the other reason why Ys are difficult to set up in routing preferences, because it really does need to be defined with all your users so that they understand you can't draw a 90 connection now because it's looking for a 45. And so if I draw off here at a 45-degree angle, you can see that that works because I drew it in the proper orientation that the Y would be placed. So if we test this again, I'll go ahead and undo, and we will go to create similar again. And now I'm going to draw that same 45, but in the different direction. And you see it doesn't work because the primary and secondary connectors on the fitting have oriented the Y to face a specific direction. And since you don't have any indication as to what that direction is, it becomes a guessing game until you get it right or get used to the workflow. As you can see here, that direction doesn't work, and the other direction, just to prove it to you guys. Oh, I love it when I have to eat my words and things work better than I expect them to. So that orientation of the Y will rotate, looks like it will rotate around the pipe itself, so that as long as you're drawing it in the right flow direction, it will go ahead and place that fitting for you. So let's go back into the routing preferences here, and let's talk a little bit about setting up multiple fittings inside a single routing preference. So I set up my pipe segment, I set up all my different fittings, but you guys notice that you'll have these plus and minus signs here. So if I'm on the elbow and I hit the plus sign here, I will go ahead and set up another, let's go grab the Charlotte elbow, let's go with the 8th bend. Go with that guy. And of course I could keep hitting plus here and plus, and I could have as many fittings as I wanted to here under elbow. Now the only way that Revit will pick the Charlotte elbow over the ABI elbow is through size delineation. So if I have this set to all and I have the Charlotte set to all, I'm going to go ahead and take these guys off of there. If I have both of these set to all, Revit will always use this ABI fitting. It will never use the Charlotte fitting automatically in the routing preference. If I use my size delineation and say the ABI goes from 1.5 maybe to 4, and the Charlotte goes from 5 to 15, now when I draw a 5-inch pipe, it's going to use the Charlotte. When I draw a 4-inch pipe, it's going to use the ABI. And of course, I can come in here also and change the order upon which I see them here. Now, changing the order, again, is only going to impact your routing preferences if they share sizes. If they don't share sizes, it's not going to matter. The size will override the order. And of course, that same workflow and same restrictions apply to the cross, the transition, the union, the flange, the cap as well. So now that we've talked a little bit about the routing preferences and how we set them up, going all the way through segments and sizes and then throwing your fittings in here, let's talk a little bit about how the fittings know that they show up under elbow or junction or cross or transition, right? So I'm going to just OK out of here and OK out of here as well. And I'm actually going to select this coupling family and we're going to edit it. Now, in this coupling family, when I'm in the family editor itself, what I want to pay attention to is this part type designation right here, mechanical part type. See how this says flange here? This is what makes that coupling able to be selected as a flange in the routing preference. It was the same functionality with the Y that we set up as a T. If we were to open that Y in the family editor, the part type would be set to T. Even though we drew a Y, the part type would still be set to T, and that's what allows it to be set up in the routing preference there. So say, for example, I could take this coupling, right? I could tell this coupling that it's an elbow. And if I tell this coupling that it's an elbow and I load it back into the project, and I overwrite the existing version, notice how my couplings are still here, right? That didn't change anything with anything that's been pre-placed or existing inside of the Revit environment. However, if I go back into my routing preferences for my no-hub cast iron, go into the type properties here, and I come here to elbow, and let's say I want to add another elbow. Now, when I come to this drop down, I have the option to add that coupling in as an elbow. So that's the role these things will play. Like I said, it's a big tip to be able to use that designation to take things like couplings and put them under the flange, because that is going to allow you to automatically place your couplings like I said. Alrighty. So upon further exploration of kind of what we've done here with the routing preferences, we obviously would want to go through and set these things up for every single pipe material that we may ever use. Out of the box, you're going to basically get one that's good, and that's the PVC Schedule 40 domestic waste and vent. Standard doesn't really help you, and chilled water is set up more like we used to set up pipes in Revit back in 2012 and previously, before we really had piping systems, right? We had to set up our pipe types as designated as system as well as material. So these are just kind of hanging out from some older methods inside of Revit that we really don't practice anymore because we have a lot of other options to be able to do that. Now, families obviously play a role inside of the routing preferences, and when it comes to the families, you can do what I've done and download some families that exist. You can obviously go through and create your own. You can modify lookup tables to create your own, which is one thing I've done for no hub families in the past. A lot of people kind of miss how flexible the out-of-box PVC families are, and how you can just simply edit the lookup tables and create no hub fittings or other fittings based upon the PVC fittings by simply modifying an Excel file and that Excel file's values. As you look around some of these fittings here, guys, we can see some obvious challenges, right? The connectors are in the wrong spot in this coupling, so I wouldn't be able to do an accurate pipe length schedule, but that's simply modifying this coupling family and moving some connectors around. I see the same challenge maybe here on the elbows, and obviously some of these other fittings too. I will want to inspect to make sure that the connectors are in the right spot, verify that even though it came from a manufacturer that it is dimensionally accurate. I've seen things like that happen in the past too. Yeah, and just getting another piece of information in here from one of the viewers of the webinar. Thank you very much. You create a sanitary pipe system with P-traps defined as elbow fittings. That's a great idea. Even at least if it's just a single routing preference is set up partially. I really do encourage you guys to take advantage of the fact that it doesn't matter where you get these fittings from, if you made them or you get them from a downloaded manufacturer, you rip them out of somebody else's project that you got, but it doesn't matter. You can still open them, edit them, and change them as far as their part type is concerned. It's just as simple as coming in here and selecting the different part type, and you can play with this functionality and have it marry with as best it can. It really the way you design pipe in Revit. I touched briefly on primary and secondary connectors. That is something to be considered for how you route your pipe. But that's something that I've covered in previous webinars, and if you guys would like me to cover that again, or along with any other topics I've talked about, lookup tables, anything like that, in future webinars, by all means, in your comments section on this webinar, please give us ideas for what it is you'd like us to cover in the future, especially if you like hearing my voice, which you probably don't, but heck, sorry guys. Anything on pipe. So, yeah, guys, it's been about a half hour here. Want to be respectful of your time, give everybody the last 15 minutes or half hour or so of their lunch period back. So before I go off, guys, is there any more questions? It looks like we have one coming in. Does data built into connectors flow through the ABI families? Great question. I haven't checked that yet. Obviously, I don't have any sources in here. But I can definitely get back to you and let you know what I found, so you can go ahead and check those families out too, and see how useful they are for you and or your firm. All right, everyone. Well, I don't see any other questions popping in here quite yet, so I'm going to go ahead and jump off the webinar here, give you guys some, oh, I got one more. Wait, it's coming. Oh, I love my clients. You guys are playing jokes on me. I love it. I absolutely love it. You guys, you realize I sit here and watch these questions come across the screen.